Hello, class. In the lecture today, we didn't have time to completely finish about the interface. I think I'll just use this video to talk about it a little bit more. Interfaces, they are very similar to abstract class. For one thing, they are primarily used as kind of the parent class. For abstract class, it can be just any regular class. So anything a regular class can do, an abstract class can do it, except you can't create objects from abstract class. And also in class, we discussed that abstract class can provide abstract methods to the children, such that you can force the children class to implement, to override those methods. Interface is slightly different. Just like abstract class, interface can provide abstract methods to the children, but they can't provide anything other than public abstract methods or public static final constants. So for example, they can't provide any public data to the children. They can't provide any normal public methods to the children, while abstract classes can. The purpose of the interface is it in general allows multiple implementations of interface. Just like in class, we say, well, for human class, it can extend mammal and also implements multiple interfaces. So both interfaces are implemented by human. So this multiple inheritance is kind of one big difference between interface and the abstract class. Okay, the other idea of interface is you can use interface to kind of put constraints on the children class that implement that interface. So for example, in our PA, we may say we have a public interface called, I don't know, like interface 1, I1. Okay, and in here you have a method called foo, public void foo. So this is the interface. If you have a class, public class, let's call this human, that implement I1, then inside the human class, you must override this method, the foo method. You must give this method a body, right? Or else the compiler will catch. So this is kind of the idea of interface, but interface is different from abstract class. So if you have a public abstract class, this class can give abstract methods like this abstract public, I forgot abstract. So public abstract, I call this foo. Then the children must provide the body for foo. In addition to have abstract methods, the abstract class can also just have normal methods, public, like void, like foo bar. And you can give a body to this method. And this foo bar will be inherited by the children. So in addition to having abstract methods, abstract class can also give you normal methods. That's kind of the advantage of abstract class. The last thing I want to talk about kind of interface is interface can also extend from other interface. So you may have interface I1, and you may have another interface I2 that extends from I1. You may say, why do we want to do this? For example, if you have a public interface I1, and in this method you have a abstract method called foo, void foo, and later on you say, I need to add another method into this interface I1. Well, you have two choices. The first choice is you say, I'll just add this method. So I'll just insert this method called public abstract method. I'll call this foobar. It returns a void. And then, I mean, you can just change this interface, but whoever have implemented this interface are in trouble because I have a human that have implemented I1. If I'm the programmer of the human class and you are the programmer for I1, then what's going to happen is I'll be super mad because I now need to implement this foobar method in my human class. If you don't tell me in advance, then I'm in trouble because my human class can't be compiled anymore if you simply update to I1. So one thing that you can do is you can basically say, well, instead of inserting this method into I1, what I will do is I will create another method that, so you may say public interface I2 that extends I1. Inside here, you add in the foobar. Void foobar. So basically, whoever have implemented I1, they have a choice. They either kind of still use I1 with no change, or they say, well, I will now implement I2 instead of I1. So this will be kind of an easy route. The other thing is, I don't want to kind of have this kind of inheritance relationship in I1. In I2. What I want to do is I want to still use the old interface, I1, but in I1 I have the foo method that is still abstract, but I may have a default foobar method. And basically you can give this foobar method a body. So the syntax is not there, but the idea in here is foobar will be a method that you give a default implementation. So now if human implement I1, human do have to kind of give foo a method. How about foobar? Human can say, I will use the default action for foobar. So human class don't have to do anything extra. The human class may also decide to say, I don't like the default implementation foobar, I will override it. That is okay. So that is kind of the keyword default in there, and that is something you might have to do. You have to do, not might have to do. You have to do for this coming PA. So I think this is kind of the discussion about the interface. We'll come back and revisit this idea a little bit more on Friday. I just want to make sure that you understand how the inheritance on interfaces work. Okay. All right, that's it. See you on Friday.